We've been working on Bohr models, and can we see and interpret the video we're watching, hunting the elements? Do we see how those two, one helps explain the other? Right? Because anytime we left off with talking about element 29, copper, element 50, tin. Why do we say element 29 or element 50? What did the host say that when you're talking about those numbers, how does that identify the element? Okay, a little bit of context. Okay, as they looked at that periodic table, they pulled out each individual square on that periodic table. He said, I think it was written here, for instance, that maybe it has this on there, and then the atomic mass, I'm just going to say is 58 point whatever. And it would also say this in there. It says copper, right? They said that this bit of information is probably the least important. Why is this number so important? Well, sort of. This identifies how many what it has. Protons. That identifies the element. This number is called what number? The atomic number. All right. So actually I got to take roll. I'll pause this. Okay. Now we're back. Okay. So with every one of these Bohr models up here, notice we don't have anything wrote or written into the nucleus. Okay. Is this, if you want to write this down, fine. As we keep working on these, we just say it's your opportunity to write this down. Okay? This, if you do, fine. If not, this probably isn't such a big deal, but how many of you feel comfortable doing these Bohr models? Okay, we see, keep those hands up. If you are unclear about these, see these individuals who have their hands up, what does that mean you can do? You can go ask them questions, okay? But whose responsibility is that? Yours. Yep, your own, right. Okay, so as we look at this, we'll just go in order. How can you tell me this is a neutral element? Why are you right? Okay, so it's got 13 protons in the nucleus. That identifies the element as aluminum. That is correct. What element is this one?
Sodium.
Okay, we say add your numbers and letters together. We typically put an E here. Why? Because 1. It's much easier to see this rather than writing a 1 like that might disappear inside your line. Okay, so this is element number 11, or sodium.
Lithium.
You're right. Why?
Because
there's 3, so it's got 3 protons in the nucleus. This one's hydrogen. Okay, what about this one? Okay, and then what is this one? Magnesium, because it's got 12. I guess I should have just wrote 1 in here rather than the H for hydrogen. Okay, so again, the protons identifies which element it is. Okay, so what do this one, I'm just going to put an X through the nucleus, this one, this one, this one, those that have an X in the nucleus, do they have anything in common?
they all have E.
Okay, that's called a valence electron. That means in each outer energy level, how many electrons are there? 1. What column is this on the periodic table? The first column. That's right. So, with that being said, what's true about this one? How many valence electrons does this have? 2. Okay, so this is magnesium, right? What column is magnesium in on the table? The second one. The column that it falls into tells you how many valence electrons it has. Okay? This is aluminum.
Third.
This is in the third column. Okay? So, with that being said, actually I didn't do this correct. Okay? This is why. It actually has 3, but to be more precise, really, it should be like that. It's still 3, okay? Because in the P block only, what column is aluminum in the P block only? The first column of the P block. But you also have these 2 over on the S block, correct? So there's those 2. This one is coming from just being in the first column here. Okay? So as you go 1, 2, 3 through 8, that tells you how many valence electrons you have. Don't do that with D block elements because they've got multiple charges to them. That's why they're called transition metals, because it can be, for instance, cobalt. It can be +2 or it can be +3. It's transition. It's either one or the other. Okay? In other words, in basketball, you go up for the rebound. You turn, you look, you throw it to the guard because you're going from defense to what? Offense. That is a what? That is a transition. You're going from one to the other. That's why you call them transition metals. Make sense? All right. So we have just a little bit of content I want to go over before we go back to hunting the elements. Okay? This is where we left off with last time. We also had asked, instructed, whichever way you want to look at it, what did we tell you? You got a little bit amount of space. What did we tell you to write on the outside of this? And you could do the same thing over here. Okay? The reason for that is each one of those little numbers you write is called this. It's called a period. It's a repeating pattern that keeps going over and over and over. That's why you might want to write those numbers on there. Okay. So one of the aspects that we see, Dmitry Mendeleev was able to classify elements' masses by according to what element? You would have had to have been paying attention yesterday to see that. Someone said it. Hydrogen. So if we see the element hydrogen having a mass of 1, okay, it doesn't matter how many marbles you put into that scale they were talking about. If it's 8 times heavier, okay, no, I'm sorry, 16 times heavier, it's going to be not necessarily 16 marbles, but what has an atomic mass of 16 on here? Right there. Oxygen. Okay? So if it's 16 times heavier, it says what? 15.99999. So if it's 16 times heavier, even though you can't see oxygen, you know that that's what that is. All right. So as we see this, he arranged this in increasing atomic mass. We talked about one place where that's not correct, and it's right here. What is tellurium's atomic mass?
127.
What is iodine's atomic mass?
126.
So you're going backwards. So that is not how this actually works. It's actually arranged in increasing what? Not atomic mass, which is what number? You said it in an indirect way. You're right, but the number of protons, which is the atomic number. Okay, so what we see here, this presented that problem, that tellurium and iodine. Elements would be out of place because of the arranging it by atomic masses. So increasing atomic number actually corrects these misplacements.
So you couldn't flip them?
Couldn't what?
You couldn't flip them?
No, because once you do that, the number of valence electrons it has is going to be out of place. Because it says What determines an element's reactivity? Is it the protons, the neutrons, or the electrons? It's what's rotating around the nucleus, which are what? Not neutrons. It's one on the outside. The electrons determines an element's reactivity. Okay? Does everyone have this content that wants it? No. Okay. Not this one, though. Do we feel a lot more comfortable with these electrons now than the first time that you had seen that? What rule did we say keep writing those on? It goes in slants, the slide rule. Once you get that interpreted, how to utilize that slide rule, it will make things a lot easier for you, because what happens is we go a little further in depth in general chemistry. So if you have that good background, not only do you do the Bohr models, the configurations, which we do here as well, but you also do what's called quantum numbers. So you have that good background, you'll be much more, let's say, successful, or well, what's the word I'm looking for? Prepared for that as juniors. Okay. I think I just want to do one more slide here. Okay. Does everyone have this content that wants it? Okay. Okay, and what do we got here? Okay, so does everyone have this content that wants it? And again, this just helps me explain this content to you. Okay, so just like what we had up on the board, look, groups are vertical columns on the table that characterize the elements with similar properties. Okay? Why do these have similar properties? What did we say they all have in common? They have one valence electron. Okay? So that's what we mean by a group. Hydrogen, lithium, sodium, and potassium. They're all in column 1. So that means how many valence electrons do they have? 1. Okay, beryllium, magnesium, calcium, and strontium. Right next door to it. What column is that? 2. Okay, so that has 2 valence electrons. Because remember, the column it falls into tells you how many valence electrons it has. Make sense? Okay. Then this will be the last thing that we write down on your packet today. Then we're going to do one example of a D block element, which we have not done yet. The biggest number that we've got to is 20. Okay? So what is element number 20?
Calcium.
Okay? What column is calcium in? Okay. So that means that outer energy level is going to have 2 valence electrons in it. And we had that up on the board. Okay? So again, if you're having problems with this, you all saw people had their arms up in the air. They can help you. You can come and talk to myself before, after school. You can probably find a junior that took general chemistry. Some of you have older brothers or sisters. I guarantee you they can help you with this. Find a senior. I guarantee you they can help you with this if you were to politely ask. Does everyone have this content that wants it? Okay. So, yes. It was supposed to be today, but notice we're not looking at that. I had it as January 7th. How many of you are done?
We need a couple more.
Okay. Now, one of the things I told the sophomores before, if you know anything about, typically it's April 15th. You can even look on your cell phones. You look on the calendar. Typically it's April 15th. Something is due typically in the U.S. by no later than April 15th, taxes. This year it's the 18th actually. But can you wait until the 15th, or can you get them done before that? You can file your taxes now. If you file your taxes now, do you have to worry about it then? No. One less thing you have to worry about. Okay? So if you have them done, that's great. Okay. So what I want you to do is pick a number between 25 and 30. 30. Okay? 30 is what I heard first. Okay? Okay. Since you had picked element number 30. Okay. Okay. Neutrons, I'm really not sure. How would you find the number of neutrons? We're going to say that it's 60. Is it 65? So 35 neutrons then. Because this is what, this is what it's based off of. This one is 30, this one's 65. You subtract the two. That's not right. Oh yeah, it was 65. 30 from 65 gives you yeah, so 65, that would give you 35. Okay, now, follow your slide rule, okay? Right, so that's 1s2.
2, 2, 6, 10.
Okay, now, it's fine that you want to go that fast, but not everyone can catch up to you, okay? With this one, I don't know if it's correct yet.
All right, here, look at mine. So here's the whole thing, and then you have to go to 4 columns, and then you'd have 2, 4, 10, 20, 26, 27, 28, and then 2 with an E.
No, there's no.
You got way too many there.
It's right
No,
here,
but
Mr.
that's the whole
McKinney.
thing. Yeah,
Oh,
that's the whole
okay.
thing.
McKinney, you're right there.
That's right. But
Yes, sir.
see, that's when I'm looking at that, that doesn't look right. His does, because you have all of them down there.
He did it for the biggest number.
Oh, okay. So, following your slide rule then, okay? This is 2s what? No. Okay? 2p6, okay? Then the slide rule is telling you to make a what? Another energy level. Okay? So 3s what? Okay? Okay? Why are you right when you say you got to make a new energy level? Because that number goes through the 4, or 4s what? Okay? This is where it gets tricky. Do we put any more here? No. The slide rule is telling you to go back down to the 3rd energy level. And what column in the D block only is zinc in? 10. Okay? So if we add all these numbers together, we've got 8. Okay? We've got 12. That's 20. 20 plus 10 gives you what? And that's what we're supposed to get. Okay? Now, we said the electrons determine an element's reactivity. Okay? So, what happens, look in Zinc's box on your table or Bob over there. What does it say? Plus what? Okay? So this is why we say electrons determine an element's reactivity. If we do this, okay, those 2 electrons are gone now. Okay? So we've got this many positive charges. That will never change with any zinc atom. But now, how many numbers do we have here? Now, again, this is not a value. It's just the charge. We know that electrons have what type of charge? Negative charges. What happens when you add these 2 together? That's why it says positive 2 inside that box, because these 2 electrons get donated. So it's got 30 positive charges, but only 28 negative charges. That gives you a net charge of plus 2.
Where'd you get 28 at?
2, 4, 6.
But why'd you take out the 2?
Because we're getting a little, it's not that we're getting ahead of ourselves, but I just wanted to illustrate why that plus 2 is there. That explains why it is. Yep. Okay, so that's where we'll stop for today. We'll catch up to you next time. We're continuing hunting for the elements. They will show you these energy levels today. For those of you, if you are listening, watching, or paying attention, this will make this much easier for you. Catch up to you next time.